Recent years have seen an increase in predictions about a potential massive solar crisis. Scientists have observed that solar activity has entered a new cycle, with solar flares and coronal mass ejections, CMEs, becoming more frequent and intense. This cycle is expected to peak soon, suggesting that humanity might face significant risks from solar storms. But how much of a threat does this solar crisis pose to humans? Could it be the end of the world, as some fear? And most importantly, what can be done to mitigate this crisis and protect our infrastructure and way of life? From March 23 to 24, 2024, NOAA's GOES satellites, along with other international partners, observed significant solar activity, including a powerful X-class solar flare and a CME heading toward Earth. The resulting G4 class geomagnetic storm, the most potent since 2017, had widespread effects, impacting power grids, radio signals, and satellite operations. Geomagnetic storms can disrupt high-frequency radio communications and even pose risks to astronauts performing spacewalks due to increased radiation exposure. Although NOAA's Space Weather Prediction Center issued alerts warning about the potential for severe storms, the impacts were limited, though power grid irregularities were reported in Canada. It was a quiet night in August 1859. The air was still and warm in the small towns of South Carolina, where most people had long since gone to bed, drifting off to sleep beneath the inky black sky. But as the night deepened, an eerie glow began to spread across the horizon. It was unlike anything anyone had ever seen. The first to notice it was a bricklayer named Henry. He awoke to find his small bedroom illuminated in a reddish hue, as if dawn had come early. Confused, he sat up and peered out the window. What he saw took his breath away. The sky was a swirling canvas of vibrant reds, greens, and blues, dancing and weaving as though the heavens themselves had caught fire. It was an aurora borealis, something usually reserved for the frozen reaches of the far north, but here it was, bathing the sleepy southern landscape in ethereal light. Henry wasn't the only one mesmerized by the celestial spectacle. People across North America, from Canada to Mexico, were stepping out of their homes, astonished at the sky's transformation. Reports of similar lights came from China and Australia. For a moment, there was a sense of wonder and awe, as if the world had been gifted with a celestial painting that few had ever seen before. But that sense of wonder quickly gave way to something darker, something unsettling. As the auroras painted the skies, telegraph operators in cities across the United States and Europe were witnessing another kind of spectacle. Their machines, the marvel of modern communication, began to flicker and spark erratically. Lines that had been silent for hours suddenly burst into life, sending streams of fire along the wires. Some operators recoiled in fear as the machines they worked with every day seemed to turn against them, sparking wildly and even igniting small fires. This wasn't just a one-off occurrence. Telegraph operators in Europe reported similar phenomena, machines going dead one moment, then springing back to life the next, as if possessed by some unseen force. Some wondered if the end of the world was upon them. But as quickly as it started, the chaos subsided, leaving behind a wake of smoldering telegraph lines and a lingering sense of unease. The cause of this upheaval would eventually become known as the Carrington Event, named after the British astronomer Richard Carrington. He had observed a massive solar flare erupting from the sun just hours before the chaos on Earth. It was a coronal mass ejection, CME, a surge of plasma and magnetic energy that raced through space, colliding with Earth's magnetic field. The Earth's magnetic field, a powerful force generated deep within the planet's core, usually protects us from the sun's more harmful emissions. It is, after all, the very reason compasses work and why we don't all get roasted by solar radiation. But when a CME of this magnitude hits, it can break through our planet's defenses, causing disruption and chaos. The Carrington event was a stark reminder of the sun's raw power and its ability to impact life on Earth. Thankfully, technology wasn't as advanced back then, so the disruptions, while alarming, didn't cause widespread damage. Yet this historical event serves as a warning. If a solar storm of this intensity were to hit today, with our reliance on electricity, communication, and technology, the results could be catastrophic. As scientists predict increasing solar activity in the coming years, the lessons from the Carrington event are more important than ever. Are we prepared for what might come next? Could we withstand another massive solar storm, or would it send our modern world spiraling into chaos? Only time will tell, but history has already shown us just how fragile our grip on stability can be. Fortunately, the technology during the Carrington event was not as advanced as it is today, limiting the impact on human activities. However, solar activity follows a cycle, typically peaking every 11 years. This periodicity makes it essential for scientists to monitor solar events closely to avoid a repeat of history, or worse. Take 2012, for example, the year many associated with the Mayan prediction of the end of the world. In December of that year, a major solar storm barely missed Earth by just a week. Scientists later calculated that its power was the strongest in over a century. If it had struck Earth, the consequences would have been catastrophic, potentially causing widespread power outages, massive communication breakdowns, and global disruptions to satellite-based technology. Some have even speculated that the Mayan prediction of an apocalypse might have been related to this near miss. What if, in an alternative reality or a parallel dimension, this solar storm had hit, leading to widespread destruction? It's a chilling thought. An event that narrowly missed our timeline might have caused unimaginable chaos in another. What if, in that parallel dimension, we hadn't been so lucky? The devastation would likely have set civilization back decades, perhaps even plunging the world into darkness and chaos. These what-ifs underscore the potential threat that modern society, heavily reliant on electricity and the internet, could face from a similar event in the future. If our technological infrastructure had been knocked out in 2012, it's easy to imagine how quickly everything we take for granted could fall apart. It would be more than just a blackout, it would be a collapse of the systems that keep our modern world running. With solar cycle 25 nearing its peak between January and October 2024, the threat of severe geomagnetic storms looms large. As technology has advanced, so has our dependence on it, increasing the potential for widespread disruptions. Imagine global power outages, internet disruptions, and satellite communication failures. The consequences could be severe, affecting everything from emergency services to financial markets. NOAA satellites like JUICs play a crucial role in monitoring solar activity and providing early warnings for CMEs and solar flares. The upcoming GOES-U satellite will carry a compact coronagraph to help detect and characterize CMEs, improving our ability to forecast geomagnetic storms. Given the risks, it's crucial to have emergency plans in place. Unfortunately, the satellite currently used for early warnings has been in operation for over 20 years and has already exceeded its expected lifespan. This raises concerns about its reliability and the need for scientific breakthroughs in satellite technology to ensure accurate and timely warnings. While the potential impact of a massive solar crisis is alarming, there's no need to panic excessively. Science and technology have made significant strides in mitigating these risks. We can improve resilience by strengthening terrestrial systems, incorporating advanced protection techniques, and ensuring redundancy in critical infrastructure. Ultimately, our interconnected world can become more robust by recognizing and addressing potential vulnerabilities. With adequate preparation and a bit of luck, we can navigate the challenges posed by solar events. What are your thoughts on the matter? Share your insights below.